So this is day 10. The lesson's called Causal Relationships, and we're going to be looking at the cool down called Just Cause. So to get started, we just need to talk a little bit about connections. Humans are wired to look for connections and then use those connections to learn about the world around them. It's one of the unique, interesting things about human beings. We always look for patterns and connections. One way we can look for connections is by looking for a pair of variables with a relationship. In order to learn how the variables are related, we want to control one of the variables and see if there are changes in the other variable. For example, if we notice that people who tend to eat many calories also have a higher chance of having a heart attack, we might wonder if lowering our calorie intake would improve our health. So one way we could test this out is we can control the calorie intake and make it so that somebody maybe eats less calories or a whole bunch of people eat fewer calories, and then we look at their rate of heart attacks. If the number of calories go down and the heart attack rate goes down as well, then we think there's some sort of a connection there. Now, one common mistake people tend to make using statistics is to think that all relationships between variables are causal. Scatter plots can only show a relationship. It doesn't mean that one thing causes the other thing, though. To determine if change in one of the variables actually causes a change in the other or has a causal relationship, the context must be better understood and other options ruled out. For example, we might expect to see a strong positive relationship between the number of snowboard rentals and sales of hot chocolate during the months of September through January. That does not mean that an increase in snowboard rentals causes people to purchase more hot chocolate. Nor does it mean that increased sales of hot chocolate cause people to rent snowboards more. More likely, there's a third variable, such as, shocking, colder weather, that might be causing both variables to increase at the same time. So, sometimes there is a causal relationship, though. A strong positive relationship between hot chocolate sales and small marshmallow sales may be linked, because people buying hot chocolate may want to add small marshmallows to the drink. So an increase in sales and the increase in the sales of hot chocolate are actually causing the marshmallow, that's a weird word, causing the marshmallow sale increase. Finding relationships with the help of the correlation coefficient is a very good way to notice there's a connection between the variables. So let's take a look. See if we understand what this means. For each pair of variables, decide whether there is a very weak or no relationship at all. We're just looking for a relationship. If one of these things changes, would we also expect the other thing to change? Do we expect a strong relationship that's not causal? So weak or no relationship. Strong relationship, but one is not causing the other. Or a causal relationship. So, would you say that there's no relationship between the number of snowplows owned by a city and the number of mittens that are sold in that city? Or would you say that there is a strong relationship between those two that's not causal, as in the number of snowplows owned by the city doesn't cause the mitten sales to be higher, or the number of mittens being bought doesn't cause there to be more snowplows owned by the city? Is there a strong relationship that's maybe based on a different variable that we're not thinking about or talking about yet? Or is there a causal relationship? How about the number of text messages sent per day by a person and the number of shirts owned by the person? Will there be a weak or no relationship? Or maybe there's a relationship that's not a causal relationship, or maybe there is a causal relationship. And that's really the question that's being asked for each of these four things. If you're still not sure how to do it, let me know.